Hello, hello. So in this video, we're looking at piecewise functions, and we're going to see a kind of typical question. So it says here that the function h is defined by this. So it's basically being split into two subfunctions, the x squared minus 12 for values when x is less than 0, and 10 minus x when x is more than or equal to 0. So depending on our domain, we're going to have to use a different subfunction. And part A says sketch this hx function, and then we're going to do some questions about it. So what I would always recommend is to first of all just sketch the normal x squared minus 12 function and normal 10 minus x function. So kind of ignore the domain and ignore that it's a piecewise function to start with, and just draw them like normal. So the x squared minus 12, well, that's just a normal x squared graph, but being shifted down by 12. So we've drawn that here in red. And then 10 minus x, that's giving me a straight line that cuts the y-axis at 10 and has a gradient of -1. So we've drawn both of those. Then we can take into account the domain. So actually, we only want the x squared minus 12 for x values less than 0. So for this part over here on the left. We don't want any of this. We kind of need to get rid of all of this bit. And because it's less than 0, not less than or equal to, it doesn't include this point here, where x is actually 0. So we put an empty circle on that point. Whereas our blue line, the 10 minus x, we don't want that one when x is more than or equal to 0. So we don't want any of this region. We don't want any of this, because for these values, x is less than 0. But because it's more than or equal to, this time we do a circle again, but the circle is shaded in. So just remember, if this is or equal to, you shade in the circle, and if it's a less than or more than, then it's an empty circle. Okay, so just to tidy that up a little bit, we'll scroll down here. This is basically exactly the same thing, but I've just written a bit more clearly. So this is what you'd want in the exam. You'd only draw one half of this and one half of this, and we need to mention all the points where it crosses the axes. So this would be minus root 12, 0. This would be 0 minus 12. This is 0, 10, and this is 10, 0. All right, so that's the answer to part A. That's it drawn. And now if we scroll up, part B says find the values of A such that our function with A substituted in is equal to 13. So for this, if we go back down to our graph, basically what we're doing is we're going up to 13 on the y-axis, and we're saying, kind of drawing a line across here at y equals 13. And we're saying what values of x do we need to input to our hx function to get about an output of 13. And we can see we must be looking at this point here, because this is the only point for our hx function where the line actually comes into contact with this y equals 13, where the output is 13. So we know that we're looking at this one. And so now for part B, all we do is write x squared minus 12 equals 13. Yes, and the whole point of sketching it here was that I know it's this one here that I'm equating to 13, not this one here. Then I can just do x squared equals 25 by adding 12 to both sides. And then I can square root. Square root of 25 is plus or minus 5. And looking at my graph, I know this is minus 5. Because it's between 0 and minus 10. It's not positive 5, it's not over here. So x equals minus 5. And that's the answer to B. That's it. So now if we scroll back up, it says solve h of x equals x. So find the value of x for when the hx function equals the x value itself. And there's kind of a couple ways to think about this, but the way that I think about it is to treat your hx and your x as two different functions and draw them both. So the x one is basically just y equals x. So we can draw the line of y equals x and then see where that line intercepts our hx function. So if we do that, y equals x would just be a straight line across here. So that's going to intercept here. and also here. So it's these 2 points that we want. So I know it actually intercepts both of the curves. So I'm going to have to make x equal both curves. So I could do x squared minus 12 equals x first. So this will be giving me this solution here. And that means x squared minus x minus 12, which goes to x minus 4 and x plus 3. So x equals positive 4 or x equals minus 3. So 2 solutions. However, looking at my graph, I can tell this minus 3 because this x value is around here. It's at minus 3. It's not over here at 4. So this here is my answer. And then I also need to do the same thing for this one. So where I let my 10 minus x equal x. So I add x to both sides to get 10 equals 2x. Divide by 2, 5 equals x. So that's our other solution. So for part C, our solutions are minus 3 and 5. And that's it. So hope that all makes sense. A lot of these questions are pretty similar. They're all based around having one function split up into subfunctions, and it's best just to draw the 2 subfunctions themselves without worrying about the domain at first, and then take the domain into account to have your proper answer. And then, yeah, these questions are often pretty similar as well. They do the same thing over and over again. But anyway, hope that all makes sense. If you've got any questions for us, let us know down in the FAQ. And otherwise, have a go at the MCQs to make sure you can practice it all, and I'll see you next time.